Welcome, ladies and gentlemen, to Fluid Pressure, Example 1, Part 1. As usual, please pause and copy this as we go along. I will stop and allow the video to run a short time so you can pause it, copy the problems and the diagram. So I ask you to please pause the video, copy this information and the diagrams because it will be easier to follow along. My name is Mr. Davis, and I am the math healer. Let's begin. Determine the total force on a dam whose inside vertical face is shaped as in figure A, with water reaching to its top. One more time. Determine the total force on a dam whose inside vertical face is shaped as in figure A, with water reaching to its top. At this time, please pause and copy. I will move the video or the slide up now. Please pause and copy this diagram so that you can follow along as I continue on. Please remember the following. A, according to Pascal, within any fluid, the force exerted at each level is equal in all directions. I left off the level or point. So again, from the introduction to fluid pressure, here is one of the important concepts that we must recall in working with these problems. According to Pascal, within any fluid, the force exerted at each point or at each level and a point in that level is equal in all directions. So at any point, the force exerted by the fluid is equal in all directions. So please remember this. Part B. Our calculations will only involve the end wall of the dam and the depth of the water. No other physical features will have any effect on our computation. One more time. Our calculations will only involve the end wall of the dam and the depth of the water. No other physical features will have any effect on our computation. Again, please pause and copy this information so that you can remember this important concepts. These two here, it's very important, particularly part A here, that the fluid exerts a force at each point that's equal in all directions. Again, please pause and copy. Now observe that we imposed a coordinate system on top of figure A to produce figure B. So now, as you see here, we took a coordinate system and we imposed it. We superimposed it on our dam. This vertical line, this is our y-axis. This line here is our x-axis. And we had it go through the center, and the bottom of the dam runs along the x-axis. So these are the coordinates at each significant point of the dam. So you will need to copy this information in order to follow along. This is very important. So once again, please pause the video, copy this diagram along with the points because it will be easier to follow as we proceed through this problem. So one more time, observe that we imposed a coordinate system on top of figure A to produce figure B. The bottom of the dam is resting on the x-axis and the y-axis is on the vertical center line. So again, please copy this information. Width of the dam. From y equals 0 to y equals 10, the width of the dam is a constant 20 feet. So any horizontal, microscopically thin strip will have a width of 20 feet. The area of a strip that is microscopically high is delta A sub I is equal to 20 times delta Y. Here's a representative diagram of that microscopically thin high strip running 20 feet across the dam from where Y is equal to 0 to Y is equal to 10. Here goes our width, and delta Y represents the microscopically thin height of that strip. Each strip in the interval Y equals 0 to Y equal 10 has a depth of 15 minus Y sub I from the top of the dam. One more time. Each strip in the interval from Y equals 0 to Y equals 10 has a depth of 15 minus Y sub I from the top of the dam. So delta A sub I times 15 minus Y sub I is equal to 20 times delta Y times 15 minus Y sub I has units of cubic feet. So this expression has units of cubic feet. The area times the depth, this gives us units of cubic feet. Now, please remember that density of water is given to us as 62.4 pounds per cubic feet. Very interesting. So our incremental force from Y equals 0 to Y equals 10 is equal to, well, delta F sub I is equal to 62.4 pounds per cubic feet times 20 times 15 minus Y sub I times delta Y cubic feet. Delta F sub I is equal to now 1,248 times 15 minus Y sub I times delta Y, and this is in pounds. So that's going to give us the force. From Y equals 10 to Y equals 15, the width of a horizontal strip will be determined as follows. W is equal to F of Y minus G of Y. So from Y equals 10 to Y equals 15, the width of a horizontal strip will be determined as follows. W is equal to F of Y minus G of Y. Had a little trouble saying that one for some reason. I don't know why. Let's go to the next page. We will now determine G of Y. We will use the point slope formula in order to do that. The point slope formula is given to us as Y minus Y1 is equal to M times X minus X1. We are using the point P2 is equal to negative 15, 15, and P1 is equal to negative 10, 10. We must determine the slope. So using the slope formula, we have that M is equal to 15 minus 10 divided by negative 15 minus that negative 10, which is equal to 5 divided by negative 15 plus 10, which equals 5 divided by negative 5, which is equal to negative 1. So the slope of that function is negative 1. So the slope, M, is equal to negative 1. And as our point 1, x1 and y1 will be equal to negative 10, 10. So for our x1 and y1, x1 is going to be negative 10, y1 is going to be 10. So taking this information, substituting it into the point slope formula, we now have y minus 10 is equal to negative 1 times x minus that negative 10. Now we have y minus 10 is equal to negative 1 times x plus 10. Well, we need to find g of y. So in this case, we're going to divide both sides of this equation by negative 1. So dividing both sides by negative 1, we have y minus 10 divided by negative 1 is equal to negative 1 times x plus 10 divided by negative 1. Ladies and gentlemen, this ends Example 1, Part 1 of fluid pressure. Please continue on to Part 2. Please let me know if this video instruction so far has been clear and easy to follow and understand. Again, my name is Mr. Davis, and I am the Math Healer. My site is mathhealer.com. Thank you for joining me.